Hello students, this is question number 14 from homework number 11. This question is going to help you find the confidence interval. The question says, out of 200 people sampled, 100 had kids. Based on this, construct a 99 confidence interval for the true population proportion of people with kids. And we're going to write our answers here to the lower bound and the upper bound. So the formula for the confidence interval is given by the lower bound of the interval is p hat minus z sub alpha divided by 2 times the square root of p hat times 1 minus p hat divided by the sample size. The upper bound of the interval is basically p hat plus z sub alpha divided by 2 times square root of p hat times 1 minus p hat divided by n. So we have from the question the level of confidence and alpha. We're going to calculate p hat based on the information we have. And from that information, we will need to find the critical value. So we will need to compute p hat and the critical value. And then we are going to use the lower bound on the upper bound formulas to compute the lower bound and the upper bound of the interval. So I have from the question that the level of confidence is 99%. That means alpha is 0.01 and alpha divided by 2 is going to be 0.005. I don't have p hat from the question straight away, but I know that out of the 200, 100 of them have kids. So x is equal to 100 and n is equal to 200. Now I want to compute p hat, so I'm going to compute it right here. P hat is basically x divided by n. So p hat is 50% or 0.5. Now we want to find the critical value. Based on the confidence level that I have a confidence level 99%, alpha is equal to 0.01, and alpha divided by 2, this is alpha divided by 2 by the way, is 0.005. So again, this is the normal distribution. And I want to find the critical value here. I will find negative z sub alpha divided by 2. And then from the symmetrical properties, I will find z sub alpha divided by 2. I know the area to the left of this number is 0.005, which is alpha divided by 2. The area in the tail, in both tails, is equal to alpha. So this area plus that area is equal to alpha, and alpha is equal to 0.01. To find one of the tails, I just basically divide alpha by 2. Now I know the area to the left of a number, and that number is missing. So I will use the norm dot s, because I'm talking about z-scores in this case, and this is the standard normal distribution, dot inverse of the area 0.005 to find the number that is the cutoff for the bottom area. So I will compute that right here. Norm dot s dot inverse of 0.005. And that is the negative value. All I have to do is just to multiply it with a negative. So I'm going to put the negative in front of that. Now I have the positive value, and that is what I'm looking for. Now I will compute the lower bound of the interval. The lower bound says p hat. So I'm going to click on the cell that says p hat minus z sub alpha divided by 2. I will click on the cell that says z sub alpha divided by 2 times square root sqrt of p hat. So I'm going to click on the cell that says p hat times, open parentheses, 1 minus p hat. I'm going to click again on the cell that has p hat, close the parentheses, divided by n, the sample size, which is 200. Close the parentheses and then click enter. So that is the lower bound. The upper bound is similar. So this is equal to p hat, this is p hat, plus z sub alpha divided by 2, this is z sub alpha divided by 2 times square root of p hat. I'm going to click on p hat times, open parentheses, 1 minus p hat. I'm going to click on p hat again, divided by n, which is 200, and then close the parentheses and click enter. There is a p hat missing, so I'm going to click on that. So this is the lower bound and this is the upper bound. I'm going to copy and paste my values into my answer boxes. And submit my answers. I hope this video helped you find the confidence interval. I will see you in a different one.